In this video, I'm going to talk about applications or starting to understand applications of problems using the normal distribution. So let's take a look at one example. This is a tire company, okay? Greer Tire Company problem. And for example, this is a common problem for many companies, but let's take a look at this one. The company estimated that the mean tire mileage for a given tire is 36,500 miles, with a standard deviation of 5,000 miles. The manager wants to know the probability that the tire mileage will exceed 40,000 miles. Okay, so this is a like fair problem. You as a manager, you want to know if the tire will last for more than 40,000 miles. Maybe marketing people want to make a promotion, I don't know, advertising, whatever, and then say that the tire lasts more than 40,000 miles. So this is a fair problem. I want you to understand some important takeaways and elements that you need in order to solve these problems. One of them is the notation to use in probability or statistics. So you see that here we have P, which is the probability of have a given tire X. X is the miles for that tire, be higher than 40,000. So how this notation is translating this problem into a more math notation. So what's the probability that the tire or the mileage will be higher than 40,000 miles? Okay, so pay attention to the notation. For example, again, P, what's the probability that a given variable be higher than any number? That's the probability of X be greater than any number. Here, this notation says that the probability of X be smaller than any number, and we also can have the probability of given probability of X be smaller than a given number and higher than any any other number in the same problem. Okay, so the first step is to understand notation. The second is you have to figure out, you have to draw, always draw, to understand what you're talking about, and also to understand if you're talking about the left or right, or the lower or upper tail of the distribution. Let me show you how to do that, how you can interpret. So we'll draw here. So I start always by drawing the normal distribution, something like that. And in this case, we have mileage or miles in this x-axis, and then they vary, right? They vary from less to more miles, the tires. So let's take a look at the problem. It was estimated that the mean tire mileage is 36,500 miles. So I know that the mean is at the center. So here is 36,500, right? With a standard deviation of 5,000. I can put 5,000 here. That's my standard deviation. So what the problem is saying is, what's the probability that the tire will exceed 40,000 miles? So first thing is, where is the 40,000? 40,000 is here, or 40,000 is, let me see, why is not working? Okay, it was backward. Okay, so is 40,000 miles in this side, or 40,000 miles is in this side? Remember, we always start counting from this side to the right side. So here we have 32,000 miles, and here we have 40,000 miles, somewhere here. Doesn't have to be perfect. So by drawing, I know that 40,000 is in the upper tail, right? Is the upper tail side. This side, upper tail. Okay, and again, let's take a look at the problem. The problem says, what's the probability that the tire will exceed 40,000? So what I'm really interested is in this area, in this tail, because what is the probability that it's going to be higher than 40,000 miles? Okay, so we're going to learn how to solve this problem using Excel. I just want you to understand how to proceed when you have a problem in front of you, what the piece of like information you have to understand to be able to move on. Okay, so this is what this figure is talking about. I thought that by drawing to you alive would be much easier to understand than this figure here, but that's the same thing. Finally, to solve this problem, you have to know the mean and the standard deviation. This is what you learn to compute in chapter 3. That's the reason you had chapter 3, because you learned how to compute the mean and the standard deviation to be able to work on probabilities. Let's take a look at one example. I'm going to use MindTap again. Let me use MindTap, and then I'm see MindTap section 6.2. exercise application. Let me show you how to go, and let's take a look at exercise 17. So this is chapter 6, section 6.2. Then I click here in the first section 6.2. And what we have is, for example, you go to this menu, and this is everything you have. You have all the text and everything. And then you go to exercise applications, and then we have this problem. The mean cost of domestic airfares in the United States rose to an all-time high of $385 per ticket. Okay, so I have one piece of information here. This is my mean. So let me draw this for you. Let's start a new a new slide. So I know that the mean, it's taking some time for, okay, the mean is how much? I'm sorry, the mean is $385 per ticket. And airfares were based on the total ticket value, which consisted of the price charged by the airline plus any additional taxes and fees. Assume domestic airfares are normally distributed with a standard deviation of 110. So if I come here, I know that it's 110. I can draw the normal distribution. I know that here is 385. That's my mean. Okay, and let's take a look at the problems. What is the probability that the domestic airfare is $5.50 or more? So if I go back to drawing, I have to figure out where is this lower tail or is this upper tail. Okay, so this is upper tail. 550 is higher than 380. So I want to know the probability. The probability that an airfare ticket is higher than 550 based on the mean and standard deviation. Okay, so let's take a look again. What's the probability that the domestic airfare is 250 or less? If we come back here, then we can draw another probability distribution, have the same mean, but now we are talking about 250 or less. Okay, so 250 or less. And we can also have, what's the probability that domestic airfare is between 300 and 500? So if I come here, let me open a new one, and then I have, again, the normal distribution doesn't have to be perfect. I want to know what is the probability that an airfare is between two values. I think it's 300 and 500, something like that. So I'm interested in this area in the middle, okay? And this, for example, this one we can turn into, what's the probability that I have a value that is higher than 300 and smaller than 500. Let me see if it shows up. Takes some time to communicate. So this is how I use the notation. What's the probability that I have a value that is higher than 300 but is smaller than 500, which translates into draw a normal distribution like that, and then we use Excel to solve this problem. There is a third kind of problem. What is the cost for the highest 3% of domestic airfares? For this problem, I'm going to use another video to talk about how to understand this problem, okay?